basically this is drift theorem here. Good morning. This is basically my tripolar self. I trust the model myself. So basically, the tripolar self is literally one better model. Once again, guys, let me get to my GitHub and show you what I mean. Yeah, drift theorem, github.com, github.com/mk2 drift theorem. Yeah, so basically here the new main file here. Yeah, so drift theorem is a self-referential vision system. It's a self-referential vision system, but I'm trying to model the tripolar architecture. So this is just a very possibly part of the system. So my computers were doing the heartfelt systems. I'm really beginning the video of the system, knowing what it does, knowing what it is, knowing what it's going to do. Well, the drift theorem, let me show you the video. So this video here I made, once again, guys. Yeah, this video. So this video here, basically, it does work, but this is very important, guys. You understand that it's got basically the Insigi firmware innovation, because business is so the Insigi firmware is literally a cybernetic firmware that gives you food, water, and shelter based on the tracking telemetry of the data. But the data is going to work from the real world. So it's not a digital or not. It makes sense of the data. I'm called cybernetics because it knows to act on the data based on probing. Probing, a question. Question is a probe. But soon answer questions literally by getting information based on what it is doing. Yes. So this drift system, this is like a static system. So I'm moving. So the system knows where it's listening to. It's not AI. Without AI system. It's not AI system. But this is the flow system. A graph, weighted G, cost, line, super, but it's gonna be tripod separate colors, But this is the film, so it's not really good well color coded, but I'm showing something here. So if I go to the GitHub page, drift theorem, github.com OBXs of Moscow, B for Bravo, Alpha Indigo, X Delta, X for X-ray, E for server MQ2 /drift underscore theorem. We get the drift theorem. So let's read this aloud and understand the. So, you know, uh, so basically, so let me just read what I'm saying. So basically, you need to switch on other camera. So, Namdi, what are you doing? So I'm trying to model this systematically. I'm saying I'm complete. I'm not perfect. So maybe I am perfect. I'm complete. It sounds like I'm not broken. I'm claiming I'm perfect. I'm complete. Definitely damage part of my body. Because since there's no break, I have to be complete first. There's no break. So this is the model here again. So the model will be this kind of see basically this is an axis of symmetry. This is one axis of symmetry. And you're gonna have two axes. So you're gonna have one axis of symmetry in the center. You're gonna have another one crossing out diagonally. So you're gonna have two axes. Then you're gonna have two axes of symmetry. Let me just try and draw that now. One second, guys. Let me try and draw that now. I've got to fold that, didn't two axes of symmetry again. Crossing the line. One more orthogonal angle symmetry. Yeah.